Hello, and welcome back to our maths today. And we're going to continue adding fractions, but this time focusing on mixed numbers. So it's adding mixed numbers to mixed numbers. Now, there's a trick to this. There's a way to make it easier. And actually, this step from what we did yesterday isn't too big, and hopefully it makes your life easier and you can see the shortcut and the reason why it's not as scary as you think it might be. So let's have a look. So the first thing I want you to do is I want you to match each number across here with the description. Now, some numbers can be matched to more than one, and some maybe multiple numbers can be matched to different ones as well. So it's just thinking about it. So pause now and have a look, see what things you think match together, and then we'll talk through it and go through it. Pause now. Okay, so let's have a look. The first one is 1/3. 1/3 is a unit fraction because it has a 1 on as a numerator. It's also a proper fraction because it's less than 1, and it's less than 1, obviously. The next one we're going to look at is 9/2. So it's an improper fraction because your numerator is larger than your denominator. It's a non-unit fraction because there's more than one piece. So the numerator is more than 1. And it is greater than 1 because, again, the numerator is larger than the denominator. The next one we have is 2 8/3. So first off, this is greater than 1. Secondly, it's written correctly because you've got a mixed number. So you've got the 2, but this part of it isn't fully done. So there's still some whole ones that are in here that should be written as this if it's a mixed number, properly written mixed number. This would be it written correctly. So there's 8/3, there's another 2 whole ones and 2 left over, which make it 4 2/3. The next one I'm going to look at is 4/7. This is less than 1 because the numerator is less than the denominator. It's a proper fraction, again, because the numerator is less than the denominator. And it's a non-unit fraction because the numerator is more than 1. Last one is 7 2/5. So this is greater than 1, obviously, because we have 7. That kind of gives that away. It's a mixed number because we've got whole numbers and fractions in it. So let's have a look. We've got 2 numbers here, 2 mixed numbers here, 2 1/7, which is this one, and 3 3/5. And we have to add them together. So you could convert them both mixed numbers to improper fractions first. So here's your 2 whole fifths and 1/5. So in total, you have this 11/5, which is there. And in this case, you've got 3 full ones, 1, 2, 3, 15 plus 3 is 18. So then you could add them together to get 29/5. And then you could simplify that down and put it into a mixed number into 4 4/5. Now, I'm going to let you into a secret. That is the long way, and there is no need to do it that way. You are making your life harder. Let's have a look why. Well, here's the question again. But this person is going to add my whole numbers together and then the fractions together. So 2 plus 3, and then our fractions together. So 2 plus 3 is 5. And then how many fractions do we have altogether? We've got 1, 2, 3, 4. Like that. And we've got 1/5 plus 3/5 equals 4/5. So our total number is 5 4/5. Isn't that easier? Doesn't that make your life so much easier? Add the whole numbers together, add your fractions together. Say, for example, you got 9/5. You could then swap that down into 1 4/5. Then you add that to your whole one, the wholes here. So that'd be 5 plus 1 is 6 plus the 4/5. That's so much easier than doing it any other way. And it means that you're not having to do as much maths. You're just trying to make your life easier. And that's the whole point. The whole point of understanding why you can do something is so that it makes your life easier and it makes maths easier. Maths is not particularly hard unless you don't understand it. And that's when it starts becoming harder and you start having to work from something you don't understand. Okay, so these are the two ways we've got. We've either got making it into an improper fraction, adding them all together, and then making it into a mixed number, or we deal with the whole numbers, we deal with the fractions, and then put it back together again. I think this way is easier, but both ways will get you to the right answer. Which way do you think is easier? Okay, so let's have a look at this next one. We can deal with the whole numbers first. So 3 and 4 equals 7. Then we can deal with the fractions, 1/4 plus 5/12. And the thing here is that we can then just use, to solve this one, we can just use our method that we have been using all along. We get the same denominator and we add them together. So you get 3/12, 3/12 plus 5/12 equals 8/12. And then we could simplify 8/12 as well. And 8/12, both these two numbers are divisible by 4. So 8/12, if we divide both by 4, we've got 2/3. So it'd be 7 and 2/3. And you don't have to do that because it doesn't ask you to simplify, but it is correct. Okay, so now it's your turn. Have a go at these two sets of questions, please, for me. Pause now and have a go. Okay, so let's have a think about this one. Question 1, well, this is just having a look at the methods. So you have to look at what they've done in each case. Teddy here has added the whole numbers together, then added the fractions together and put them back together again. Whereas Mo here has done them as improper fractions, added them together, then put them as a mixed number. You can like either way first, but you can see that this looks much easier to do than this one here. And that would be my idea. I would go with Teddy on this one. Whereas our answers to 2, add your whole numbers together, 1 and 2 is 3. Then we've got 3/10 plus 2/5. 2/5 times by 2 to get to 10. So that would be 4/10. 4 and 3 is 7. 3 and 7/10. 1 and 2 is 4. Then I've got 20ths, fourths. So if I was doing this one, 3/4 plus 3/20. Well, I can leave the 3/20 as it is. I have to times 4 by 6 to get to 20 here. So I've got times this by 6 as well, which is 18, like that. Add them together, 18, not by 6, by 5. Sorry, I knew I was wrong somewhere. It's 15. Add those together, you get 18 over 20. You can divide both of those two by 10. And that's where that 9/10 come from. But you could have it written either way, I don't mind. Then we come down here, add the whole numbers together. 1 and 4 is 5. 3/16. Add on 3/4. Well, I have to times quarter by 4 to get to 16. So times that 3 by 4 as well to get to 12. Then add them together. 15/16. And there's our answer. And then we go over here. So 2 and 2 is 4. 2/5, 3/5. 2/5 plus 3/10. Times that by 2 to get to 10. Times that by 2 and get to 4. That equals 7/10. And there, that's that. And you keep doing the same thing. And you should get to those answers there. None of these, the fractions added together across the boundary. Okay? So, have a go at these two questions now, please, for me. Okay, so let's have a look. how can Wrong improve his answer? So he's done 2 3/5 plus 1 7/10. He's added the whole numbers together to get 3. Then he's got 13/10. And he's left it like this. Well, the problem here is the problem we were talking about before is this is an improper fraction. We can't have a mixed number with an improper fraction altogether. So we have to exchange the 13/10 for the mixed number. So 13/10 is the same as 1 3/10. So 3 13/10 is the same thing. We can add the 1 3/10 on and remove that fraction to get 4 3/10. So that 13/10 we just change into 1 3/10. Add them together to get 3 plus 1 is 4 plus 3/10. 4 3/10. And then the same goes on here. This is just checking to see. You do 2 plus 3. Equals 5. Then you do 3/4 plus 5/12. Times that by 3 to get to 12. Times that by 3, you get 6. With 9. 9 plus 5 is 14/12. 14/12. I can take a whole one out and have 2 left over. Sorry. I can take a whole one out and have 2 left over. Divide both of those 2 by 2, and I get that. Add the 1 1/6 to 5 gets me 6 1/5. And the same process, we do the same by this would become 2/12. Then we can add them together, which would normally be 8 13/12. We can take another whole one out, add that to the 9, and have whatever we got left over, which is 1 here. In this regard, we've got 3 and 2, which is 5. But we can change this, times this by 4 to get that as 12, times that by 4 to get 8. Add the 2, 8 and 7 together to get 15. Then we can take another 12 out, so that would be 5 15/12. So we can take 12 out from there, we're left with 3, making that 6. Then 3/12, we can divide both of these 2 by 3. That's divided by 3 gets 1. That one divided by 3 becomes 4. There's your answer. Same here, we got 6 plus 3 is 9. Then if we times that by 3, we get 15. Times this by 3, we get 9. 7 and 9 added together is 16. So I can take 15 out of there, left with 1, and add 1 to there. And that's our answer. Okay. And obviously you can't quite do it the same way as mine, but you would write it as you go along in your head, much like I've done over here. Okay, so problem solving question. We got a rectangle which is 2 1/15 of a meter. So in this rectangle, each longer side is 4/5 of a meter longer than each shorter side. So what's the perimeter? There's 1 meter each. In this rectangle, each longer side is 4/5 longer than each shorter side. What is the perimeter of the rectangle? So what we do, you can have a think, see what you think, but let's just go through it. So here we have it. 2 1/15 meters long. In each rectangle, it's 1, I thought so, 1 4/5 of a meter longer than each shorter side. What is the perimeter of the rectangle? Maybe there was a problem with that slide. So if this was 2 1/15 of a meter long, then this one would be the same. That means this here will need to be 2 1/15 plus that bit that's longer, 1 4/5. So we have to change that into 15. So we're timesing it by 3, which puts it to that. Then we can add them together. So the 2 and the 1 go together to get 3, and the 1 and the 12 to 13. So it'd be 3 and 13 15ths, and that would be the same on this side over here. And then we can add all the sides together and find our rectangle. So we do 2 and 1 15th plus 2 and 1 15th plus 3 and 13 15ths plus 3 and 13 15ths. So we would do 2 plus 2 plus 3 plus 3. So 3 and 3 is 6 plus 2 and 2 is 4, which is 10. Then we do 28 15ths, we do 13, 13, 26 plus 1 and 1, which is 2 plus 28. And then we take 15 out of that because that makes another whole. So we've got 11 and 13 15ths. This is slightly harder because it is involving, first off, bits of information from shape and perimeter and bits of information from fractions. So you're mixing two domains, math domains together, which is slightly harder, but it's the sort of question they might ask. But it's not just that either. This is a 4-step question because you have to work out what each side is and convert that to mixed numbers. You have to do addition of fractions, then you have to do the addition of all sides and then convert that to a mixed number as well. So there's lots of steps to it. So don't be surprised if you find it harder, but you just need to look at the information there and see if you can work it out from what they're saying. Okay, so have a go at these for me. Try your best. If you run out of time, spent too long already, just do up until the hour. Have a go, see what you can do. Pause now. Okay, so let's have a look. Question 5 and 6. So it says the blue ribbon, so this ribbon is 2 4/9 meters long. The yellow ribbon is 3 2/3 meter long. What is the total length of both the ribbons together? So what we're doing is 2 4/9 and adding that on to 3 2/3. The first thing I'm going to do is just make it so that I've got the right number of knots. So this I have to times by 3. So I have to times this by 3 as well. Then I can do my addition. So 5 wholes and 10 ninths. Then I can take 1/9 out of that, leaving 1/9 and an additional whole. And there's my answer. Then it says a red ribbon, which is 1 meter and 5/18 meters longer than the yellow ribbon. How long is the red ribbon? So it's asking you, it's starting, it says it's longer than the yellow ribbon. So we use the yellow ribbon to start with. And then it says we're adding it because it's longer than that. And then we're asking for how long that is. So we can add the whole numbers together. The first thing we're going to do is make this into this. So we're timesing by 6 to get to 18, times that by 6 to get to 12. Then we can add our whole numbers, which is 4. We know it's over 18 because we've got the same one now. 12 plus 5 is 17. And there's our answer. Okay. Then it says calculate the perimeter of the triangle. We've got all the edges, so we're just adding them all together. So 3 2/7, adding that on to 6 11/14, and adding that on to 8 4/7. So the first thing we need to do is put them all in terms of one denominator. Well, these could quite easily just times by 2 to get to 14. So we times this by 2 to get 14, times that by 2 to get 4, times this by 2 to get 14, and this by 2 to get 8. And then we can add our whole numbers together. 3, 6 is 9 plus 18, 8 is 17. Then we've got a fraction over 14 because our denominator doesn't change. We've got 4, 8, and 11. So 11 plus 8 is 19 plus 4 is 23. And then from that, we can take a 14 out, leaving us with 9. And then we add that 14, the whole that we took out, to the 17 to make it 18. and that's our answer, and that's where it goes there. And it's just thinking every 14 I take out of this is one extra whole. I move that onto there. So I take 14 out of there and put it into there. So I minus 14 from that side. No, it adds one whole one here. And it's just remembering it's whatever the number is here. And that's converting between mixed numbers and improper fractions. Okay. Thank you for paying attention during this lesson. I hope it made sense. I hope you had a go at least at some of those problem solving questions. I know they can be hard, but it's just trying to think about what we can remember and what information we have that we can take forward and help ourselves with. I hope that makes sense. Good luck, and I'll see you in the next video.